Okay, so that was our arrays example. I've made a union project, and I've made a union worker class to start with, just to get a little start on this. So a union worker has got their name and whatever their job title happens to be, and we're just going to record their title, and I put in a toString so that we can print out information about whoever happens to be in the union. Okay, so there's one union member, and so now the job is I want to make go up a level and make the class that keeps track of the whole membership list. Okay, so I'm going to make a membership list class. Okay, what information do you want to store in your member list class?
Employee number. First and last name.
Got to store all the union members. So let's use, but well, let's pretend we don't have array list, and let's regress and use arrays. So we'll need an array to keep track of all of the people who are in our union. So what I'll do is I'll make that would be a single worker. And if I want to make a bunch of workers, then we'll use the array notation to do that. Just like with any Java class, we have a constructor. So I'll make public member list. Maybe it has a name, don't have to worry too much about it. And we have to initialize the all workers array. So that's going to be a new worker array. And then we get to the nasty thing about arrays is that we always have to specify how many people we want. So I'm going to start out with a small union. I'm going to say, oh, I think the maximum number of people I'm going to have in my union is 20. Okay, so there's our membership list all set to go. How do we get people onto the list? Add them, so we need an add routine. The kind of thing that's coming in is a worker. It's somebody new who's never been on the list before. Where do you put them in the array? Might as well put them at the first empty position, so that's, I mean, always start out with the specific thing here. That would be, let's put them into all workers sub 0 would hold on to that someone. Okay, but now you know the next time you add the second person into the list, that's going to be a problem because it'll overwrite position 0. So now you know, I guess this thing needs to be a variable instead. So we need the name for a variable as to where we're going to put them. So it could just be spot. Sure, that's fine. So that means that we need another variable up here. And where should spot start? Okay. We're not going to worry about errors yet. We're just going to handle the simple thing. So after you've added somebody into position 0, now spot needs to go up 1 position to fill the next position. Okay. Let's talk about that spot variable for a second. Spot is a sort of a generic word. What's the interesting thing about that particular spot? So one thing that you could do is we could just change this and we could say, rename it and call it end of list, which is probably a little bit better. Anything else that's interesting about that particular end of list spot?
Empty spot on the list? That's the last spot.
In other words, well, let me put it this way. Suppose I started, well, I guess I can't do that. Yeah, it's got to be empty, right? Because you wouldn't want to overwrite something that's there. So let me just try a different name change here, and instead of calling it end of list, let's try one more time with refactor, and we'll change it to next empty spot. Does that look better?
Yes.
So now when you see this line, it's more obvious that I'm putting something in a spot that I think should be empty, and now next empty spot needs to go up to say we're going to fill the next empty position. Okay? I'm really concerned about that empty, because one of the things that you could do to this code is you could actually start that variable instead of at 0, you could start it at -1, and then you could turn around and change the order of these things around. And that code will still work. Okay? And so and if I just called this, we'll put this back to spot here for a second, like we had originally. We'll just obfuscate it a little bit. Now look what happens to trying to read the code. It's a little bit confusing because the spot variable doesn't tell you enough about what's interesting about that position. And so when you get here, you don't know whether or not you should set it to -1 or 0. And when you get it here, you're going, well, that's weird. Why are they incrementing it and then putting it in? Wouldn't it be better to put it in and then increment it? And so what you sort of try to do is you go, well, that -1 looks a little strange. Let me change that to 0, and now it's broken. Okay? And so if you can put it, the whole idea of using those good variables is so that it becomes obvious when you're reading the code, it makes more sense. Okay? So now it always makes sense to say I'm going to put something into a spot that's empty, and now that I've filled that empty spot, I guess I can move on and talk about the next empty position and remember what I'm going to do with it. Okay? So getting the right name will help you get the code right and avoid a lot of errors. Okay, so there's, we've put people in. How would we retrieve them? If somebody wants to look at,
You'd want to select that number, that person.
we need a getter to send things back. What do you want the getter to look like? What kind of thing is it going to send back? If you put workers on the list or in the array, you're going to get workers out of the array. We'll call it get. And what information are you going to give it?
Integer number. So you'd want to just type an integer.
Where it is on the list. And so now you can send that thing back as return all workers sub where. Okay. Again, no error checking for a start. If they ask for position 5, you just give them position 5. Well, that's okay, but how would somebody know when to stop? Get me 0, get me 1, get me 2, get me 3. How would they know when they'd reached the number of people who were actually in the union?
Use a for loop to count through them.
Get that next empty spot to find out where the last enter would be.
Yeah, so this variable is keeping track of not only where the next empty position is, but that is actually the number of people on the list. So if next empty position is 2, then spots 0 and 1 are already filled, 2 people on the list. Okay? So this variable is actually serving a dual purpose. It's both where put the next person, but it's also keeping track of the number of people on the list. So if we want, we can write public int size and have it send back next empty spot.
Empty
Or
spot.
sorry, it'd be +1s.
But if you have 21 on the list, so why would it be +1?
It's gone past that last person.
What do we do instead of arguing about that particular detail? What's the easiest thing to do to find out? Better than debugging.
Into that.
Oh, you've forgotten all your 132. What would be a better option than trying to debug something? Test it using. So let's go to writing a unit test to see whether or not member list actually works. So there's member list test. We'll include our setup method, add the libraries. And the joy of the test is that we can also use it to try things out, just get some sense of how it works. So let's make a union. Well, we need a few workers first. I'm going to make the workers up here. So there's worker A, here's worker B, and here's worker C. We'll give them values in setup. And that has to be some name and some job title, which really doesn't matter. So I'm just going to avoid the whole issue. By the way, one of the things I'll point out here is that in Comp132, we'd be really interested in the worker class. In Comp139, the worker class is basically just test data or fodder for the stuff that we're doing, and so we tend to just make sort of garbage little things that we don't really care about anymore for names for things like workers. Okay, it's not going to matter all that much. So what we'll do is we'll make a few sample workers. So we'll make worker B with whatever information they have, and we'll make worker C with some information. And I guess we have to make a new member list. Let's make the member list for a start just inside the test. So this is member list, all workers. It's a new member list. And we said we could add stuff, so we'll do workers.add A. How do you know A's on the list now? There's the get function that we wrote, so we'll retrieve the 0 position. How do you know you got the right one? So I think that the retrieved guy should be exactly A. How many items are on the list?
There's actually one.
There should be one. I'll put that test at the start. That workers dot size should be exactly 1 at this point. If we want to do a little bit more of a test, this is maybe too much work in a single test, but when we first make the member list, the size should be 0. And if we want, we could add some more workers. So there's add B, and we'll go and this time around retrieve the number 1 position, and when we retrieve the number 1 position, it should be B. And one more time, just to be sure, we'll do that all over again with C, and we should get C out of position 2. And just to be really sure, every time I add one, just to make sure it doesn't get written over, I'm going to retrieve both. Oops, got that little mixed up. Even more mixed up. I'm going to flip those around a little bit. And we're going to retrieve the 0 and the 1. And the first guy should be A. And the next guy should be B. That looks a little bit better. And let me just do that same thing again after I add C. And I think that got that right. There's a good test. So notice I got a little paranoid there. Not only did I check to make sure that the one I added was in the right position, but I also went back and double checked to make sure that all of the other ones were still where they belong and that they hadn't somehow gotten thrown away somehow. And I guess we should check the size just to be sure. So after we've added B, we should now have 2. And after we've added C, we should now have 3. Okay. That's maybe too big a test, but that's okay. We're in a little bit of a hurry. Run the unit test, and it conveniently adds all of them onto the list, and we're in pretty good shape. Okay. Suppose that somebody in the unit test, not the best place to put it, but we'll put it there anyway, does this. Suppose they do a print line with the workers variable. What would you expect to be printed out?
Just a random number.
What would you like to be printed out?
The list of workers, but you need a for loop for that.
It would be nice if I mentioned the name of the workers variable in a print statement that it conveniently prints out the list of all of the people that are there.
You need a for loop for
Would
that.
be the nice thing. So let's go back and look in member list. Member list doesn't currently have a toString. And we said that the usual way to write this was to just make something to send back to start with, and then figure out how to fill it in. So the thing that we've got to do here is when somebody says, I want to print out all the information about this object, we really want to give back a list of all, or a string that contains all of the workers that are on the list. So how are you going to do that in the toString? For loop. For loops always start int I equals 0, I is less than maximum number.
The
How many
size of
people
that
are on
area.
the list?
You go with the size of the area? Or just go with the size?
Careful. Careful here. It's not right. It's not the 20 because there's really only, in our example, a maximum of 3 people on the list. And so we only want to print out the people who are actually there, not the ones who aren't. And so in that case, that's I is less than next empty slot, which is the same thing as size, really. go through all of them, and what would you like to do?
Print out their name.
Let's just retrieve one of them from the array for a start.
System layout.
So if you wanted to get just one of those workers out of the array, where would you find?
An array name by I.
So all workers is the name of the array,
All workers I.
and that variable becomes I. So all workers sub I will give you back a single one. And now, how do you tack on his information onto the return variable? If I just do that, what's who actually giving back at that point?
It's just adding
Memory.
numbers.
Just to be specific here.
Whatever it is, two
What's in the two strings?
It's-
It's appending it onto a string.
Right, this is being appended to a string, and so that's really the same, just to be more specific, as calling who.toString. That's what the compiler actually does for it. So I'd actually put that there just to make it a little bit more obvious that that's what it's doing in this case. So that says take every worker information and append it onto the string. Now, just to make things a little bit clearer, what I'm going to do here is I'm going to put in a square bracket or something around each one of these individuals just so that I can see them. So I'm going to do maybe this. Add a square bracket onto the front of it. And maybe add a square bracket onto the end of it. Let's see what that looks like. Just to try to see the individuals. And out of interest's sake, in my worker class, I was nice enough to add the toString. And so if we run the test and just print out what we get, there's name and title. My toString needs a space in it. Just to make things stand out a little bit more. Okay, so there's the 3 items that were added onto the list, just out of interest's sake. Okay, so the whole point about the toString is that you have to make the toString go through all of the items on the list that you've got, because that's the expectation for people who are trying to print it out. Okay, and I'm just going to get rid of that in the test because I don't like to see print statements in tests. There we go. Okay, so there's our membership list. It sort of works to put people into the union. What's the next situation that's going to happen with our union? You want to remove some? Sure. Let's suppose that somebody dies. Let's see. Let's write a test. First, this was AdWorks. So let's try writing a test first. And maybe we'll write the general case because it might be the easiest one to understand first. What I'll do is I'll add a bunch of people onto the list. Oops. We'll add A, we'll add B, and we'll add C. We'll steal our membership list declaration for the new test. Now we've got a bunch of people on the list. Which one would you like to remove?
Move A.
remove anyone, sure. Workers dot remove, in this case, A would be the number 0 position. And then if you looked at your list, what would you expect to see?
Expect to see A gone.
If A is gone, what's in the list now? B and C, what position's B in?
B's 0.
So I think that we'll start out with the size of the list. Workers.size should have shrunk down to 2 instead of 3, and I think that workers dot get the person at position 0 should be B, and the person at position 1 should be C. Okay, does that seem like a reasonable test? Okay, so let's go into member list and let's write the remove method. And we'll start out by making remove do nothing. And just out of interest's sake, now that it does nothing, oops, needs a position. I'll just run my unit test just to make sure it fails for a start, and sure enough, remove fails. That's a good thing.
To remove position.
So now what's going to happen with remove? If we draw a picture, pictures are always good. We've got something that looks like this. There's our array of all workers. And what we've got is something that looks like this. Here's A, B, and C. And somebody comes along and says, remove A. In our diagram, this is where next empty position is at. What do you want to do if somebody says delete 0?
Well, you'd want it to be on the position.
So if that one goes away, then whoever's at 1 needs to slide back, whoever's at 2 needs to slide back, and now that position there is going to be the empty one. So this variable needs to slide back and refer to that potentially. Okay, so we've got to go through all of the positions past this one and slide them in that direction. So the guy who was at 1 moves to 0, so they're all moving -1 direction. Okay. What if I said remove the number 1 position instead of the number 0 position?
Everything beyond number 1.
So everything beyond number 1 has to move backwards for however many they are. Okay. Now you have to write the code. What's the code going to look like?
A for loop using position to remove as the beginning value.
So starting thing, it has to be a for loop. And it just has to be a for loop because you've got more than one thing that has to slide backwards. And so we'll just start I at where?
0.
I think position to remove is 0 point.
So it starts at position to remove. Sure, could start there either. Could start there too. Position to remove +1. I is less than what? And I goes ++. So it's as usual. What item are you going to move? It's coming from the array, which is all workers. What position are you interested in?
Position to remove.
It's the I position you're interested in. Where do you want to move it to? In the array, still at all workers sub I -1. So at least that portion of the code says take them from where they are now and move them -1 towards the beginning. So that line of code makes sense. Okay? And you've got the loop that goes through hopefully all of the ones that have to move in order to do the work. Okay? Anything else that you need in the code? Next empty spot has to do what? Has to go backwards to the previous position. If you want to make that, clear out that position, all workers sub next empty spot. Since it had something in it and now it doesn't, needs to be empty, which in this case is null. Because after you move this guy from 2 into 1, then that 2 spot has to be cleared out, and then this variable needs to slide back to refer to it. Think it'll work? Well, let's just run our unit test and see what happens. That seemed too easy. Let's go back and look at member list. How's that code for understandability? It's sort of ugly. Okay. Here's the reason it's ugly. The reason it's ugly is because that variable I is trying to do 2 different jobs. It's trying to keep track of what the interesting position is, and it's also trying to keep track of how many times you have to do this. Okay? And what typically happens with people when they write this sort of code and they try to get it to work is that, see all those pluses and minuses in there? If you don't get it right, the game that you play when it doesn't work is you go, oh, okay, I guess that shouldn't have been +1 there. Let me take off the +1 and see if it works. Oh, no, that still messes it up. Let me go change this -1 instead, because maybe that's the problem. And the reason for that is that if you change I here to try to get the position, the number, the count right, you might get the count right, but then you get the position wrong. And so then you change I in terms of thinking about its position, and when you get the position right, you get the count wrong, and so you go back and you try to adjust the count. Okay? And so what I'm gonna do here is I'm gonna try to separate out the ideas here, and I'm gonna leave I to just count the number of items, and I'm gonna make a separate variable to keep track of the position I'm interested in. Okay? So let's do it this way instead. Let's go here and let's make a variable that says position to move. What's the first position that I want to start moving? Next empty spot -1. Okay, because is that right? Think about this for a second. If somebody comes along and says, I want to remove 0, what's the first one that has to start moving? Number 1. So it's actually positioned to remove +1 is the first one that starts to move its way, work its way down. Okay, so it's not next empty spot -1, but it's actually position to remove +1. Okay, so if somebody says remove 2, 3 is the first one that's going to slide back into the 2 position. So it's always one past the one that you're trying to remove. Okay, and now what I'm going to do, now that I've got that, I'm going to change this loop here to say they move from where they are now to -1 of where they are now. We're gonna get rid of, we're gonna change this in a second. Okay. Now what I'm gonna do is I'm gonna change my loop, and I'm just gonna make the loop count, start at 0 like we normally do, and go through an increment, but I only want it to go through the number of things that actually have to move, which I'm gonna call items to move. And let me make another variable here. How many items do I have to move in general?
You have to remove that size of that array. So
If somebody says remove the 0, 1, I have to remove everything from that one to that one, which is that number minus that number. Okay, so I take the number of items minus whatever the +1 position is, and that should give it. So the number of items to move is, we'll just do it this way for a second, the size minus well, what the heck? This is where Mr. Debugger comes in handy, now that I've got things in separate variables. Put a breakpoint there, run with the debugger. And remember, this was removing the 0 position. So there's my array of things. Let's go dig out the array of things. There's all workers. All workers has got 3 items in it. And the position we've asked to remove is the number 0 position. So the first position to move, doing a step over, is the number 1 position. The number of items that have to move should be 2. Oops. And it says 3. Okay, so there's where the debugger is your friend in doing the calculation. I know that that should be 2. Okay, so the easiest thing to do, kill it off, go back here and say it's the size minus that minus 1. Change a 3 to a 2. And now let's just run it and see what happens. Run our unit test again. This time all the way through. And oops, it died again. Let's just see why it died. It says, I don't think that the number 1 item is C. Let's go see what the number 1 item is. We'll put the breakpoint there. I've got another breakpoint in there, but we'll take it off in a second. We'll run with the debugger. Get rid of that breakpoint and let it run again until we hit the end. Crack open our array. So here's the workers array, and it's got same thing twice. Okay, and just out of interest's sake, that same thing was B. So we didn't get C copied. Okay, let's go back and look at the code again. Position to move variable needs to change inside the loop. After you've moved 1, you have to say, now I'm going to advance. It's the next position that has to move down 1 spot. Give that a try. And that one works. Okay. Let's go back and look at this code for a second. Let's start with this line of code. If you're just looking at this code, is that line of code correct? Take something from where it was and slide it up 1 position that way. That line of code's got to be correct because that's what the diagram says. After you've slid this one, the number 1 position, minus 1, then you move on plus plus to the number 2 position. So this line of code afterwards that says position to move plus plus is correct. Okay, so that line of code is correct. How many items do you have to move? This loop is correct because you just go through however many you have to move. Okay, so the way this code is written, when I look at it, you can intuitively go and look and say every single one of those lines of code is correct. Which means the only place that you can have an error in this code is either in that line where you're calculating position to move or in that line where you're calculating the number of items to move. Okay? And so the joy of writing it this way is that what we've done is we've narrowed down the problem when we go to find out what's wrong with this code to it's only in one of those 2 lines. okay? Because these lines of code as they're written just have to be correct. The problem with the other way of writing it, when you use the loop control variable to do two different things at once, is that you're stuck with having to debug everything out of the loop in order to check and see whether or not things are working properly, and you've got I playing the role of two different things. Okay? And what I've done here is I've eliminated the loop as being at all interesting from the thing. It just has to be correct, and the only thing that can go wrong is whether or not you get those two variables set to the wrong place to start with. Right? Which is going to make the code easier to debug in the long run. Okay? In the 1970s, when people wrote code, they wanted to make that I variable serve two different purposes, because that meant you only had to use one register in order to keep two different ideas going at the same time. In modern programming, you don't want to do that because that just messes things up, and so you're always better off to make extra variables to keep track of specific things. And notice in this case, my loop still counts the number of items, and that's all it does. And so its job is always just counting things. It doesn't get involved in worrying about where the position of things are. There's a separate variable that keeps track of the position. Okay? And so this style of coding in the long run is going to be easier to understand and easier to debug and probably more error-free than trying to wind everything into one for loop. Okay? So now we've got remove to work. What else is going to be broken for tomorrow? What's the next big deal? How many people can I add to this list? What happens if I add more than 20?
It's not gonna take it.
The program's going to die. What can you do to fix it?
Good argument.
We know when we add whether or not we've run out of room, and so what we're going to do tomorrow is we're going to make add smarter so that if it checks when you go to add something, and if there's no more room, it will automatically grow the array for you, do the work of all of that sort of stuff, so we don't have to see it. Okay, so that's tomorrow. Bye. I know, I'm the one who